Great to see a full house. Welcome everybody. This is the first of our Concrete Elegance series this year. My name's Elaine Toogood, Senior Architect at the Concrete Centre, responsible for curating these. And hopefully, I mean, we've got a great turnout tonight. And I'm really excited and interested in the projects we're going to see tonight. But then that's why I choose them. You know, I always choose the projects and the speakers that I want to hear about. So I'm trying to group them in a theme, and loosely we've talked. This one is being about facades of distinction and complexity, really unusual looking buildings and gorgeous looking buildings, and not just on the outside, actually on the inside too. But that was my strange link that we made. So anyway, welcome. If any of you don't know, this is Concrete Elegance has been running for a few years now, probably about a decade, and it's a collaboration between the Building Centre and the Concrete Centre. The Concrete Centre, we produce Concrete Quarterly, which hopefully you've all picked up your editions there, and so we're the central technical marketing hub for concrete in the UK. So just, you know, hopefully inspiring you to use concrete and answering questions and just generally talking a lot about concrete, much more than I ever did when I was running a practice. So you might be interested to know that Concrete Quarterly is very shortly going to be still free and available online, as it has been forever, but there's also going to be a subscription for it. So if you want it sent, I mean, you get your free copies by coming to Concrete Elegance, but if you couldn't make it, there is going to be the availability that you'll be able to subscribe for not very much, 25 quid a year or something, and you get it directly to you. So just let you know in case you're interested. And we will be celebrating 70 years of Concrete Quarterly this autumn. So we will be having a big exhibition outside and having an event called Cafe Concrete in here, and so hopefully we'll watch out for that. It's going to be really great, and a whole series of talks and lots of things going on. So closer to home, the Building Centre have got a exhibition that they wanted me to mention, or not, a presentation that they wanted me to mention in the evening on the 28th of this month, all about the Serpentine Pavilion that's up at the moment. So have a look at that. And also put in your diaries that the next Concrete Elegance is a little way off, but it's the 27th of June, so the date's been fixed. I'm just going to scout around for those exciting buildings that I think I know what we're going to have, but I can't tell you yet. So we have four speakers tonight, and the first we'll be talking. We have Friedrich Ludewig from ACME and Charlie Scott from Watermans. We'll both be presenting the fantastic work that they've been doing in terms of redeveloping the centre of Leeds and Victoria Gate building there, which will start, and then we'll be followed by Stephen Chance and Wendy De Silva of Chance de Silva. Now, unfortunately, Scanner was going to be part of that presentation. He's the musician and composer that has helped evolve that. Unfortunately, he's not well today, but we do have the music, so it's still going to be very exciting. So there will be chance for questions after each one. And then afterwards, please do come and join us for a drinks reception outside, where there'll be more chance to mingle, network, ask the speakers your questions without needing to put your hand up. There are a couple of seats. There's one seat down here. There's another one here if people want to come and sit down to the front. So I'm going to hand over to Friedrich. Thank you very much.
I won't say much about us, other than that as a practice, we are 10 years old this year. This is one of the first competitions we've ever done to work in Leeds, so it is very much kind of one of the very, very early things we've done. We try to do interesting things, not just with concrete, and we try to do it in a couple of places. So this is one of the closest ones to home. We have done quite a few elsewhere, and about 35 people from the office have actually worked on Leeds over the last 9.5 years, of which quite a few are actually here. So it's certainly not just me, it's a lot of other people who stand behind that. You may or may not have been to Leeds. So we went to Leeds 10 years ago for the first time. It's a quite beautiful, previously quite rich city, not quite as rich in the moment as it was about 150 years ago. So when you see it from 1820 to kind of 1840, when they really started getting quite rich based on wool and cloth making and providing wool to Savile Row, Leeds went through an incredibly fast period of kind of Victorian expansion. So within a period of about 60 years, basically the city became a really kind of rich bourgeois city, and our site that you see in red is quite close to the center. So kind of this is Brigade, that's the head road, that are the two kind of big streets. That's the second oldest street of Leeds. Without any involvement of the Germans, it has become a bit less bourgeois and a bit less full in Leeds. So by the time we got to site, it was basically 2 buildings and 2 surface car parks. That isn't how it was a while ago, but that's kind of what happened.
And a police station.
And a police station. So that's kind of Leeds before it exploded, and then kind of that's how much change there was within 50 years, how much change there was in 100 years, and that's how it was when we got there. So in terms of history, there wasn't much history that you could kind of immediately find. There wasn't a lot of context. There's 2 listed buildings, which are not, so there's a kind of old chapel which was converted to the Hoover offices and then totally gutted and replaced with a couple of concrete floors inside, so the chapel is gone, and there's a petrol filling station. The rest is pretty simple, 1920s Blomfield and some of it older. That's the surface car park on the one side, lovely police station which wasn't in the site at the time. 2 buildings from Reginald Blomfield inspired, and then another surface car park at the back. Leeds city center is kind of up to here. So if you actually look at the planning guidance of Leeds, it does actually say that we should be part of the retail core. It just is a surface car park, so it isn't quite, strictly speaking, probably part of the retail core. So that's the beautiful arcades of Leeds, which is the Grand Arcade and the Central Arcade, Victoria Quarter, then Kirkgate Market, which is quite special from 1904, Land Securities Development, but generally a quite dense, compact city center, one of the densest ones in the UK. And what the city very much wanted was somehow for that to become a complete core that you could walk within 5 or 6 or 7 minutes, which actually has all the main department stores of this country, and ideally kind of everything from kind of aspirational to quite middle of the road to quite kind of cheap and simple. Leeds has been declining quite a bit in the last few years. That is the retail ranking that is generally published by Experience. When we kind of got there, Leeds had been falling for quite a while, so you kind of see that there's Edinburgh and some other kind of young upstarts kind of trying to establish their way above Leeds, which very much thinks of itself obviously as the capital of not just Yorkshire. So part of what we were supposed to be doing for the council and for others is really to lift Leeds back into where it should be, which is to sit with Birmingham and with Manchester as kind of 3 equal great cities of the north. So we were quite young. It was our first year, 10 years ago. We weren't very many. And we started speculating a little bit. We were invited for a competition to design one John Lewis building up here. That's the mathing we were given. It wasn't our master plan. Don't ask why it is configured in that way. That was by others. And we were asked to do something special for John Lewis. And John Lewis has done some special buildings in the past. That's Peter Jones on Sloane Square, which we thought was quite beautiful. One of the first curtain walls in this country, and also ever since the refurbishment, I think it still looks as good as it did more or less for the opening. In my previous life, I had built this building for John Lewis in Leicester, and that hadn't quite opened yet in 2007 when we did the competition, if I remember correctly. And I think John Lewis generally kind of found transparency quite difficult. And so after having fought for 4.5 years with John Lewis about transparency, and John Lewis still not being happy about it, we kind of thought maybe this time around we should do something totally different. And we should actually do something which tries to have an interesting effect without using transparency as an effect. Because if the guy inside doesn't actually want to do anything, transparency doesn't really work particularly well. And so we felt kind of Leeds is very much a city of cloths. It's a city of woolen cloth making and kind of weaving and production of cloth. And we thought there's probably something interesting one could make out of that if one were to work with very simple elements in the same way as yarn is 2 or 3 colors of cloth woven in a certain way to create an effect, a 3-dimensional pattern, also a color and shade pattern. And so there's a couple of nice concrete projects we looked at. You probably have seen the Junaoki one in Ginza, which is kind of, it's a concrete panel with alabaster cast in, which looks quite nice at night as well. So it kind of plays quite well with not being transparent, but still having a sense of light coming through. But then we thought we're actually in Leeds, and there's Henry Moore, and we should be doing something a little bit more sculptural. It shouldn't be quite as flat. Because actually, when you walk around Leeds, it's actually, the facades are incredibly rich. They really had money about 100 years ago or 120 years ago. And you feel that it's York stone, it's a quite buff stone. It's something that we felt one could probably do in reconstituted stone. And it would be quite nice to try to find a 21st century answer on that sense of kind of sculptural expression that the old facades have. And so what we thought is maybe it would be actually quite nice to work with very simple elements. Both of these buildings, this is actually brick, but let's just assume it would be, this is actually concrete, are both made with very simple pieces that purely play with rotation. So that's a very simple brick element, rotated and bonded. That's the simple precast blocks, just sitting load-bearing on top of each other with a slight twist from line to line. So we kind of felt it might be quite nice to actually build a facade that is like a piece of fabric, that actually has a sense of being like a curtain. And it actually does that just by working with very simple concrete elements. So we could basically take a picture of a curtain, and we could assign a certain grayscale value to it, which, as you know, that's a normal kind of white to grayscale value. So we could read out a curtain as a numerical pattern quite easily. And we could work from that and could script that into something that actually rotates simple concrete elements based on a pattern. And we could probably quite easily recreate a curtain out of that. Wasn't quite as simple. And then we kind of thought, actually, we're going to get really shut by the competition guys who are going to judge this, because they're going to say it's going to be really expensive, and you have to actually do every single piece separately. So we kind of thought, okay, we probably need to have, if we want to win the competition, probably need to actually say that somehow this could be modularized, and you could actually build this out of a simple number of repeating elements rather than saying everything is totally different. So if one were to say we are buying a sample set of molds, let's call it 8 or 10 molds, and we would actually place concrete elements in the mold and then cast normal concrete at the back, we could probably build a facade that feels like it is a continuous fabric, but one could play with rotation. So that's a couple of tests, and how some of those tests of rotating elements could work and produce shadow in the surface with different size of elements, how much you actually have to come out to actually create light and shadow. Then we thought it would be quite nice if we could actually make them rotate, because it would be the same piece. We would pay the same price, but it would actually look very different if you could actually use them in both directions. So you just have to make sure the stitching works well between the two. And there's a panel sitting behind that, which you then going to start repeating. We need to think about the toothing of how do you tooth panels into each other so you don't get large vertical lines, that the eye will go up. And then we felt actually we could probably get this to work. This is an attempt at the time of scripting that facade and then working it backwards into panels. So we basically have a simple set of repetitive panels. Let's call them A, B, C, and D, and then 2 molds for each, and then let them rotate. And then we had to admit the entrances will always be specials. So in order to achieve those kind of details that one builds around the entrances, those ones will have to be kind of custom made. That's the simple set of elevations. You see the rotation in some of them. So there's, in order for that to kind of be interesting, the green part, one needs about 4 pieces plus rotation to make it work. We were quite flexible how to make it out of concrete. We kind of preferred to actually just do it off-site, but we said if you really want to, you could probably also backfill it with concrete in situ if one really wanted to do that. Couple of sections at the time, and then the images that we've used, day and night view. And it is a very flat facade, and it is quite interesting how much light and shadow and how much play one can get out of just playing with very simple repetitive elements that have a depth of never more than 250 mil coming out. That was the view of the corner at the time, and a view up in a night view. And then we won the competition, which was great, as we were quite young and it was a big building. And then the credit crunch came along about 6-8 months after that. So the project was put on hold for about 2 years. And afterwards was a competition, and we won the competition to be the new master planners for the Leeds project. So that was our second competition. And as part of the competition, we had to shrink the site, because the site was too big, the project was too large. In credit crunch times, everything had to be a bit smaller, a bit more humble. And part of that was we had to move the John Lewis. So John Lewis previously was in this kind of, not sure you can see it, kind of triangular thing over there. So we had to move the John Lewis over here, which meant we have to buy less stuff, and buying less land is a good thing because it makes everything a bit more viable. And so that was lower ground, upper ground. And then we tried sticking the old facade on the new building, and we kind of thought that isn't really going to work. Because the old building, you could never see a big part of the elevation. It only ever had a small bit that was visible, and you always perceived, when you walked along here, when you walked along both sides, you very much perceived the facade while walking along it. So the play of coming out a little bit was really powerful. When you actually stick it on a really big box and you put a public square in front of it, it doesn't quite work the same way. So we kind of felt this is probably not the right answer anymore. But we still quite liked the idea. So we thought it would be nice to recycle the idea quietly somehow. So what we did is, that's phase 1. So that's the project I'm actually kind of talking about, plus that police station that we've killed in the meantime. we got invited to another competition a little while later for that stuff, for the other non-John Lewis part of John Lewis. So we thought maybe we could recycle our John Lewis department store into something else. We kind of thought Leeds is a city of kind of quite civic buildings. They should be quite tall, but they don't really go on forever. It wouldn't be appropriate to have 3 buildings which has the same identity. It should be 3 different buildings with 3 identities. There should be what is a question mark, which is an arcade. There should be a department store next to that, and there should be a car park at the end. And they should all maybe talk to each other a little bit, but be clearly independent, standalone buildings. And the neighboring context around us is incredibly brick. And all the special buildings in Leeds are stone or a kind of York stone color, but the normal buildings are actually brick. So we can also probably, for the other building, we're probably more normal. We should be more normal. So John Lewis should be the special building. We should be the infill. So we kind of thought maybe we can actually do something interesting with infill. That's the plans of the building more or less as it was built. It's the ground floor, and that's the roof plan. So you see it's a kind of twin arcade, and it has a casino sitting on top. So it's a kind of 4-story building on this side. It's a 2-story building here. And the arcade just kind of creates a looping circular space that sits against the John Lewis building on the right side. And that was the renderings at the time. This is a compromise. We wanted something slightly wilder. The planners didn't want anything wild, so this is a compromise between not wild at all and a little bit. So basically, we tried to say there is a way of working with brick, which still gives us something quite 3-dimensional, but actually works within the context and with the buildings opposite from Regan at Longfield that we are supposed to be related to and with whom we are supposed to have a conversation. So what we did is we went to Catley, and Catley are a lovely brick manufacturer, and we got them to, they're quite good at hand making some bricks, and they make normal bricks. And the reason why we like them as normal bricks is because if we wanted to build a concrete facade with a brick face that is 3-dimensional, the brick is going to stick out. And if the brick sticks out, a normal brick doesn't like water at the top. Normal bricks only get water from the front. And the normal tops aren't made for getting water. So you have to use a brick that's actually quite water impermeable, which is basically more like a brick you would use in your driveway. A simple, kind of very impermeable on all 6 sides. That's some of the production drawings that we've made. So that is kind of us actually drawing it. And that was very much explaining to the concrete guys, so this is Sorb, what we're looking for in terms of repetition. So we've tried to find as many possible elements of repetition. There's 3 different depths. There's 3 different heights. And there's a bit of different width, but to try to say there is a quite simple set of molds that you have to build. And this is Sorb's response. So we've drawn everything in Revit between Watermans and us. We've handed over everything in Revit to Sorb. Sorb have built their own models backwards from that for the concrete scheduling. That's Sorb's drawing of that, and that's the precast concrete yard. So the way this works and the way this is interesting as a precast, as a concrete facade, is because basically the quality we were looking for, the complexity we have, and the kind of speed we need cannot really be achieved on site in the moment with the skill base we have on site. And the nice thing, if one kind of builds it like that, is one can achieve an incredibly high quality of brickwork, concrete as a composite. So this is placing half bricks face down in a mold. So that's the molds that you see kind of when you go to Sorb before they cast anything on it. Then you put spacers in it to reduce the weight of the panels. And that's afterwards, because you can basically cast them and then point them by hand while you stand in front of you. So the quality of pointing is amazing because you're not on a scaffolding somewhere up 20 meters on a ladder. That's one of the precast panels. The general weight limit is about 20 tons because the tower cranes can't lift more than 20 tons. So that defines kind of how large the pieces are. A couple of images of the yard and the finished panels, which left us with the other competition. So we were invited for a new competition to do a department store. And we said, we still want to do a building in Leeds that actually speaks about cloth, and it still speaks about a 3-dimensional facade. It should be a civic building in Leeds. And there's a couple of themes that are quite common to Leeds. It is very much about texture. There's very 3-dimensional backgrounds. There is a bit of terracotta, and they do quite a lot of amazing buildings which are marble. So it's an artificial terracotta in the same way as reconstituted as a kind of artificial stone. This is very much trying to look like stone. And many buildings in Leeds that you think are York stone are actually a kind of marble type terracotta from Beaumartin Fayence Works, which was one of the big fayence manufacturers of the time. We would still like the building to be very contemporary. We don't really want the building to look like it's 1960s or 1805. And that was a very long discussion between John Lewis and us as to kind of how much can you take them on a journey to something which looks a bit more special, and at what point does the building start to look too expensive and too luxury, because John Lewis actually don't want to become a luxury department store. John Lewis should be for everyone and shouldn't look expensive. It should actually kind of strike a balance between quality and affordability. We would still like to express function, and that's a problem because John Lewis will change their mind over time. So what we've done is we've worked very hard with the team, some of which are here, to try to find the best possible compromise between transparency they need now, transparency they may need in the future, and lots of areas where they really don't need transparency. When you look at the use of that building and you map it onto the facade, there's a lot of areas which really don't want transparency. So when you actually map what really can be transparent, there's a lot of parts which really should be opaque, and there's quite a few areas where they just want to put a shelf. And you sell things with shelving, you don't sell things with views, so it is a limit as to kind of how far transparency you can achieve in this building. And I think for us, the example was very much Selfridges Oxford Street. If you look at Oxford Street Selfridges, it's a totally filmed off building, and nobody has ever complained because actually there is enough sculptural depth in the Selfridges facade to actually have power, shadow, light, and difference. And so that's what we were trying to kind of say. It doesn't need to be transparent. It could be an opaque building. We just need to find a way of working with a material that is deep enough to cast light and shadow and articulation. And we could have not achieved it without doing it in reconstituted stone, because the depth we were looking for was too much to be able to afford that in stone in this country, in this age. The ground floor is very simple, because the ground floor is the one point where John Lewis were keen to have shop windows, so it's a very simple orthogonal grid. Above that is a diagrid, and the diagrid gives you an incredible amount of flexibility. It is kind of starting from vertical and then slowly leaning, and then leaning a bit more. So it gets finer as you go up and as you kind of stop seeing in a bit more. And if you really want the building to be transparent, and if you wanted to start to look through that facade, that is how open the facade could be. However, there's not very many openings in the building where this is, because this is basically the place to eat, which is a John Lewis restaurant. There's very few other points where they want that much transparency. So the question for us was very much, if you don't want that much transparency, what else would we do? And so that's our sequence of infill panels. There's this large sequence of ribs that you can basically fill into that. And as John Lewis, between John Lewis and us, we've worked very hard to basically oscillate between those two, to kind of say some parts will be transparent, and some parts will have different parts of infill, sometimes pure rib, and sometimes rib with something that maybe relates to the context. So that's the final mix of a typical bay. So John Lewis would be able to say, basically, in some areas we want glass, in some areas we want a little bit of glass, and in some areas we really don't mind anything, in which case, as an architect, we will be there to do something else, which will have still enough light and shadow to apologize. So that's a view of that building as you look up from the inside, and the view outside. So this shows one of the infill panels of pure concrete with concrete elements set in, and a mix between a terracotta and concrete infill. We've tried hard to make the entrances bigger. So this is oversizing the entrances into triple height entrances and then adding transparency to that so that it has a proper sense of arrival. And then we've tried to very much separate the buildings between so that you have a difference between those as you walk. Unfolded elevations that go with that, which tell a contractor which infill panel goes where. Charlie will speak a little bit about what we've tried to achieve with the atrium, so I won't bore you with that. And then the last thing we've done on the facade is to say the part that sticks out furthest should be polished concrete. Everything else can be acid etched. And that was important to us because we want the building to age well for 50 or 100 years. We want the rainwater that will inevitably hit Yorkshire eventually to run off something which isn't just acid etched concrete, as acid etched concrete won't age quite as well as polished concrete will. So this is us debating whether we needed hand polished or whether we would accept machine polishing of the joints in between, and we didn't actually get this. This is actually two pieces hand polished with a slightly soft joint. The actual one afterwards is sharper because both of these pieces were produced separately and then placed upside down. So this is us debating pieces. That was the first sample pieces. And the final solution was to say, we're going to cast the main ribs. We're going to polish them on the table. So there's a very simple polishing process. You put them again, and you're done. You put them back in the mold, and you cast the rest of the panel around that. So that's a proper panel. That's 5 meters 10 tall. And again, 20 tons is the size limit. So that's, and then there's a little bit of terracotta that sits around the ground. And there's a bit of terracotta that sits in the upper parts, which is meant to be made from 4 pieces that you can rotate. So that's a bronze terracotta tile, and then because it's a hexagon, you can rotate it into 6 positions, so it doesn't look repetitive, even though it's always the same piece of hexagon. View up. And then we've worked hard with Charlie and Watermans to achieve no vertical joints. There are horizontal joints, and we are kind of fine with that because actually you can't see them afterwards, and we have managed to get all the joints dusted. But vertical joints are, I think, the one thing we're most scared of because you really see when things are suddenly panelized, and so for that reason you see all the panels, and Charlie will speak about more, always have the joints in line with the main ribs.
Right. I'll just give a little introduction to the structure, how the frame evolved, how it had to respond, and so that it could actually work with the facade and with the architecture, and hence how we've got the frame that we've got. And it was very heavily influenced by the facade, the choice of frame. But before I get on to talking about the frame, I should just say this is the team, or some of the team who are involved, some of whom are here tonight, and it was very much a collaborative effort. We had to work really hard to deliver this building. It is a challenging building, but it was a very rewarding building. There aren't many jobs where you finish it and every single member of the team is begging you to go to Leeds with them and go and look at it because it's so good. You know, we've been up to Leeds many times to go and look at this building just because we're so proud of it. Just as a very quick frame overview, Leeds is very good for, it's got good ground, so we could put a heavy building on there without big foundation costs because we've got rock. We're basically bedding it straight onto rock. So where we didn't have basements, we had to put short, stubby rock sockets onto the top of the rock, but the main frame is concrete floor slabs. We've got some concrete cores, and then we've got a steel frame, steel lattice around the outside of that, and I'll get on to why we put the steel diagrid around the outside of it. But it's quite rare in a retail building to have a flat slab soffit, but it was something that Freddie had been talking about for quite a while with John Lewis, and they wanted it for here because it gave them a really robust surface to fit out against and very clean soffit for flexibility of fit out as well. That's the internal floor plate. It sits with a standard John Lewis grid, 1.2 modules, and we've got 2 wider bays in the middle of grids of 10.8, and then cut out through the middle of it, but with no columns around the perimeter, we've got a central atrium. So each floor is very simple, clean cast, flat slab, 350mm thick, and then we've got a thickening around the middle to achieve the atrium of 475mm thick. And then they've got a back of house area for plant and storage where they wanted actually the slab level to be lifted up an extra 85mm, which we did just buying. They wanted a screed on top, but we got their agreement to do it with a floated finished floor there, which gave us more structural efficiency because they had quite high storage loads in there. And then we've got a series of concrete cores which carry the lift shafts up through the building and some of the stair shafts as well. So most of this presentation is, and I haven't got that many slides, but most of the presentation is about the facade, but I think it's just also worth talking about the central atrium because we had escalators running up through the central atrium. We didn't want any columns around the perimeter of it because it's their main circulation space, so they wanted good sight lines up and down through the atrium. They wanted the column step back from it, and they wanted, and in order to sit with the planning grid for the John Lewis building for the rest of the floor, that generated a cantilever of about 4.8 meters and a column-free space of 21.6 meters. So it was quite a difficult structural ask. So our first chat with Freddie was to say, can we have some backspan beams on here so we can achieve the cantilevers? And that was ruled out both by Friedrich and by John Lewis because that wasn't in accordance with the agreement for lease. They wanted flat, clean soffits. So we were left with a conundrum, which we solved by, how does this work? By rotating the span of this thing and spanning diagonally across the corners of it. And we could then, just with a thickening local to the atrium and that central bay, get that cantilever to work. And that reduced the effective span to 14.5 meters, and it generates a very effective space for John Lewis. But the main challenge on this job wasn't the atrium, it was how we support and work around the facade. Now, this was the original facade elevation that we were working with. I think we've got a few more solid elements in it, but there weren't a lot of continuous vertical load paths where you could put a nice vertical column into this building, which is a challenge for a structural engineer. We quite like columns to go straight down buildings. But so we mapped on where we got available vertical load paths, and quite often they'd come up and then they'd hit a window on a higher floor. And it soon became apparent that we were going to have to align the columns with the diagrid arrangement that we had in the facade. And it also, our commitment to making sure that no structure went past these windows was also followed through onto our concrete walls, which even have diagrid holes through the concrete walls. So when we settled on the diagrid frame, we all quickly identified that we then tried to work out how we would support the panels. Now, as Friedrich said, there's no way you want to put a joint straight down the middle of one of these clean-cut mitered corners, because any misalignment, any tolerance within that will be read dramatically. So we agreed a panelisation with ACME, which, when we first started looking at it, we thought we'd put 2 points of support on the bottom of each one of these panels, which so we could bottom stack it on the slabs, divorce it from our structure, and then just provide restraint at the top. Now, each panel has its centre of gravity, and for the lower floors, the centre of gravity would sit within these two supports. But as you go up the building and the lean gets more pronounced, the panels then started to have a tendency to want to fall over. And we would have had to have braced each one of these panels off a corbel underslung off the ground floor, off the slab above, in order to fit them out. So, and also where you've got windows opening out here, you get some quite slender elements of concrete, precast concrete, which again, you wouldn't want to stack the whole weight of that panel onto that slender leg. So we worked with Concrete and ACME to look at a different arrangement of supports, and it again became apparent that we were going to have to use the diagrid as the method of support. And so we identified a critical series of structural elements where they could load direct onto them, actually sit the corbels that would support the precast cladding direct onto the structural elements. Now, the reason we didn't say you can do all of these is because every corbel you put on one of these is a cost premium, and it means we have to design that member with very stiff splices, and there's a whole different structure. It's very costly if you were going to load every single one of these up with corbels for these masonry. So we limited them to a series of, to an agreed profile of supports, and that generated, if you look at the support points on these panels here, it's much more closely aligned with the centre of gravity of each panel. So it was a natural solution for the building. The diagrid structure also had added benefits that we could help create the extra wide openings at ground floor by using the diagrid as a truss. And this is a view of the frame as exposed. And also there was quite a turning circle into the loading bay here for their HGV trucks, where we weren't allowed a column. So we were able to use that whole elevation of the diagrid frame as a truss. We worked very carefully at trying to come up with the least costly and least obtrusive connection for the concrete slab to the diagrid structure. And actually this profile here works as a perfect shear key. So the concrete sits onto that node because of the profile of that. So we only had to add in extra reinforcement in here for disproportionate collapse and tie forces. So it's quite a cost-effective way of using the diagrid's geometry. Then we had to find a way of analysing it. And there's a fellow over there called Bart who dreamt diagrids for about 6 months. The guy would have nightmares about diagrids because he'd be working so hard on them. Because we had to build a structural model that dealt with this. We then looked at the response of it, and the diagrid is effectively a truss on elevation. and it's very long and locked in by cores. So we then had to look at whatever second order effects that had, because as you progressively load it, it might get locked into the stiff cores on either end and start behaving as an arch. So it had some quite unforeseen structural responses that we had to then produce some very involved structural models to test. Then we had to take into account the Techcrete loading. So they wanted a big bracket welded onto the side of each one of these diagrid members with a point load applied to it, which then applies both two axes of bending onto our columns and a torsion onto it, which we've then got to quantify and design and test for. So in order to analyze this whole frame, we had to generate 80 different load cases, taking into account thermal effects, second order effects, and then every single node on here had to be tested. So we had to find the critical node and then go and look at the biaxial stresses going through this node for every one of our 80 load cases. So it's quite a difficult design management task. So we came up with a whole statistical data management tool where we built a point cloud of all of the envelope of data to go and identify the critical load cases. That enabled us to look at an envelope around the outside of that point cloud, which was the critical cases and the critical loads, and we were able to limit the amount of work we did, which meant when Techcrete 2 weeks before we had to issue our construction information, came up with a whole different set of loading data. We were able to process that. And just giving you some of the stats to show you how we would never have been able to process it without this form of data statistical analysis. There are 600 diagrid members, 400 nodes, 900 splices, and we had 80 load cases. So for every diagrid member, we had 48,000 diagrid member load combinations, 32,000 node load combinations, and 72,000 splice load combinations that we had to find a way of processing and getting the right data to our fabricators so that they could fabricate it. If we'd given them the maximum axial load, the maximum bending moment, and both axes and the maximum torque, they could never have designed that connection because it's more than the capacity of the member. None of those happened concurrently, so we had to use that data management tool to find the critical cases that would then define the splice load design. Whew. It was quite stressful, and just explaining it's hard work, but you imagine poor old Bart having to actually do the analysis on it. And then we also had to make sure we were choosing the right sections, so we built a whole design verification ratio chart and then tested the member sizes to make sure we weren't poking beyond the unity value, but weren't also really close to the bottom here where we weren't making them work hard because we would have got shot by our client. So data management, it sounds geeky, but it was pretty important to us. And the other thing that wouldn't have been possible, it was some pretty high-end analysis going into that, which enabled us to do the statistical and data management analysis. We used BIM software in collaboration with ACME, and we trained all of our engineers to work as in Revit. So rather than having a separate drafting team, all our engineers were trained in Revit so they could go to coordination workshops and cut sections through every single one of these stair cores, test the diagrid interfaces with the stair landings, and make sure everything worked. And I strongly believe that a building as tightly engineered and as tightly detailed and crisply detailed as this would have been very hard to achieve without all of us working with a compatible platform.
So just very briefly finish. We started construction about 3 years ago to this day. We have demolished a couple of buildings and a police station that kind of got in the way alongside, and so we've nearly finished. I think the only thing you will notice if you spot it cleanly enough, and which you should notice as we've mentioned it, is that there is terracotta missing. The terracotta is missing as we were trying to engineer a product that doesn't exist. There is actually no metallic glazed terracotta outside which can withstand Yorkshire acid rain, and therefore it is still in production. And it will get there, and we are going to lean on our client as much as we can. We appreciate any support anybody else can give to say that of this terribly ugly building is there's no terracotta. It is finished, and the roof of the restaurant isn't quite there. So I think we're a couple of months away from actually kind of fully completing phase one. That's the view looking down, so that's arcade building on the side, and then one of the most transparent parts of John Lewis. And we didn't have much lighting, so lighting is very much kind of trying to graze the concrete from the lowest point upwards, and then it just kind of dies as it goes up. The contractor didn't notice until quite late that the glass is curved, so that was a bit expensive for him, but we kind of said it is actually kind of can't be changed with a fillet. It has to be a fillet, it can't be mullion, and they've survived. What you do see, hopefully, is kind of the jointing of the project is really nice, because we've picked a big fight about duster joints, which the contractor didn't find super normal. But we would recommend it to anyone. If you ever write a specification, you have to say it should be duster joints, because otherwise you get glossy silicone, and duster joints just means that somebody puts the sand that was used in the concrete mix into the silicone when they're finishing it, so therefore it looks like a mortar joint, even if it's silicone. View alongside, so that's kind of, you see anything that is kind of a bit too flat, actually there's something a little bit missing. But other than that, you hopefully see that there's quite a lot of light and shadow against the solid parts of the facade. So this, for example, is also good lift. This is the best plant screen we have ever designed. This is a plant stack, and actually all of this is plant louvers that were made by somebody in Yorkshire who kind of just got the drawing and just got on with it, and it's possible to have a plant screen that isn't orthogonal. Yeah, the first parts of terracotta on the left side, so that's the kind of ground floor terracotta when John Lewis couldn't make shop windows work. And then the building, Yorkshire's on a slope, so kind of, there is steps. So on one side, something is level, on the other side, you're actually walking already past the service yard. So this is kind of, it's level on the other side, but a bit of concrete to apologize for that. And what's quite nice is if one works with, we've worked really hard with Diagrid on the mix of the concrete that you've seen. So we've spent, I mean, we're not as bad as Chipperfield. When you see Chipperfield sample room at Diagrid, it's much bigger than our sample room at Diagrid, but it still took 3 or 4 months to actually get the sand right. So it's a Ballylusk sand. It's a quite yellowish sand with a white cement, and then kind of enough acid etching to get the sand to actually kind of start to take over the kind of power of the color of the concrete. View up, so this is polished, that's all polished, and you see that is polished and that's acid etched, and there is some silica in the concrete mix, so actually kind of when you acid etch it, you get a bit of sparkle on the concrete. View between, so building 1 and 2, roof sitting in between. It is the same facade inside and outside, so you could demolish the arcade and the building would be happily standing on its own. View with the roof of the arcade hitting the John Lewis, so the roof is trying to talk to the John Lewis in a language that actually relates to the diagrid. And then the brick facade on the other side, so this is the half brick that you've seen that Sorb produced. So it's as a contract job in terms of cladding. Diagrid is John Lewis and Sorb is the arcade and the kind of concrete over there. Black plinths on one side, and then a bit of a view up just before the kind of final kind of signage and lighting went on. There's a corten steel element on top as the contractor kind of, and we had to design a rooftop restaurant last minute, and so we didn't have any weight capacity left in the frame, so it's a lightweight box in corten, which hopefully will age in a color quite similar to the brickwork, so it should actually blend in. Very large precast elements, which are jointed in parts, and then here not quite jointed, so that photo is how it actually looks like. This is just before they're kind of jointing it. So it is meant to look like a monolithic piece with a very limited color differentiation between the two. And then very brief view inside. So it's a 21st century arcade. It is related to other Leeds arcades. So in Leeds, we hope this makes sense. It might look a bit funny outside, but they have amazing arcades, and that's very much with whom we're having a conversation. And we're very proud to have managed to design all the shop fronts, because quite often in those kind of schemes, the shop fronts are done by other people. And so it's been a big achievement. We feel that actually we've been allowed to finish the inside and the outside. So it does feel like a very different space to something where inside everybody can do what they want. There's a bit of artificial ceiling sitting up there with an oculus that goes through to get daylight in through some parts. And then a building we haven't talked about, so on the other side, which you don't need to care about very much, as there's absolutely no concrete in it whatsoever. But there is a car park, as John Lewis wouldn't have come to Leeds without a car park. So the car park is John Lewis sized, and it's quite big. It's trying to have a conversation with the concrete without mimicking the concrete. So it's trying to work with a very simple, naturally ventilated, twisted aluminum fin, 6mm aluminum. So they're very much trying to replicate some of the visual effects of the concrete facade, but in a very different material that's a bit more appropriate to the function, which is the car park. So when you get close, it's a car park, but when you see it from afar, it looks a little bit like its neighbor. Good, thank you.
Thank you very much. Wow, what an extraordinary amount of work that went into those buildings, but absolutely worth it. I mean, really opulent. I can't wait to go. Can't wait to go. Steve Chance and Wendy De Silva to talk about their amazing and a very different scale of building, but equally beautifully complex and rhythmic up in North London. So over to you guys.
Okay, hello everybody. I'm Steve Chance, Wendy De Silva. As Elaine said, sorry that Scanner couldn't make it tonight, but he injured his back yesterday. Wendy stepped up at very, very short notice to say what we think Scanner might have said if he'd been here.
No way, but I'll try.
Thanks very much to the guys from ACME and Watermans for showing how to make very, very fine precast concrete. So now for the rough stuff. Right. How do I get into the first slide? Well, I'll tell you what. So, oh yeah, that's right. It looks different on the laptop. First thing I'm going to do then is play a bit of noise. I can find that one. What's in the background here? It was over this side, wasn't it? Good start. No, it was over here, the video. Yeah. No, the video. That's not that one. So, you left it over here, didn't you? You left it over here, didn't you? So, shall I close that? Okay, right, so here we are. If you can't hear this, then speak up and let me know. So we're going to start part of the way through here. Here somewhere, I think. The noise of concrete being poured in our project Vex, which is a new house. So that was the pouring of the whole, or it was part of the pouring of the exterior skin of right, now go on to this thing, I think, of this building. So this is Vex, which is a studio house in Stoke Newington, which is in situ concrete building, which has spaces for living and work and bedroom spaces. So it's a kind of live-work house. And this all started a few years ago now, good few years ago now, on a site which was brought to our attention by people who lived in the street, friends of ours, and they brought the site here, which is among the trees, and said that it had been a derelict site for many years and was a nuisance in the neighborhood, constantly fly-tipped, and wouldn't it be nice if Chance de Silva could put a nice little new building there. And they'd seen some of our other projects in London Open House. And so we started probably about 7 years ago, first of all, trying to negotiate to buy the piece of land which had 3 derelict garages on it, and then to go on to get planning permission for a new house in a conservation area. Now, at the beginning, we started out and we always had the idea that we would do a collaboration. And in the past, we've collaborated with a number of artists on projects that we've done. So we've collaborated with a number of visual artists, photographers, glass artists, and we have collaborated, for example, on this project, Casa Danza, with filmmakers and choreographers to make a dance piece, which was at our project Casa Danza. But we always thought it would be a good idea if we could work out how to collaborate with a musician or composer. So we had the idea that we would collaborate, and we approached Robin Rimbaud, who's known as Scanner, and pitched to him the idea that before either existed, the architecture and the sound or music would both take inspiration from an external source. So this idea came from the practice of the composer John Cage and the choreographer Merce Cunningham, who in the 1950s and 60s devised choreography where Cage would compose the music independently, Cunningham would devise the choreography, and then they would come together only in the performance. And things would happen accidentally because of the nature of how the sound and the dance related, which was not planned. So we had this, that image came from Scanner actually, and is a visual, I can't remember the name for it, but it's a sonic sort of three-dimensional visualization of a piece of Eric Satie's vexations, or vexations, which is what we decided. So that what we said to Robin was, the architecture and the sound will take their inspiration from a piece of music, which is Eric Satie's vexation or vexations, which is a piece which was apparently found stuffed down the back of Satie's piano after he died. And nobody's really sure whether this piece of music was supposed to be serious or a joke or something in between, because there's about 3 lines of music for solo piano, but the instructions at the top say, if you are going to play this piece 840 times, then you really need to prepare yourself carefully. I paraphrase the French for that. So the idea was, if you play 840 times in a row, it lasts about 18 hours. And in the early 60s, I think it was probably the first performance of it, was again organized by John Cage, and he got teams of pianists. They play about half an hour each in rotation, and it went all day and all night. And Wendy and I had been to some parts of performances, and so we pitched the idea to Robin that the building and the sound would have as a point of reference this third work. And I'm going to play a bit. That's right. I'm going to play a bit.
They're not 18 hours.
No, just.
And actually, it was a 70th centenary year last year, so I don't know if any of you caught it, but it was played at Cheltenham Festival and various other festivals.
Wendy's going to say something about Scanner.
Well, I'm a poor substitute for Robin, but I'll tell you a bit about him. So apologies to those who come, especially to see him. I met him when I worked with him on a design council competition, which is about reducing violence and aggression in accident and emergency departments. And what struck me about him was how open-minded he was and how enthusiastic and inventive he was about everything that he went to approach. So when it came to this idea that we wanted to work with a sound artist, he was the obvious choice for us to go to. And for those that don't know him, he really does defy categorization. His stage name is Scanner, and that was taken up from a device he used for picking up radio waves and mobile phone frequencies, which he then used as instruments in his compositions very early on in his career. And actually there's a tiny bit of an echo of that in this collaboration, which we'll talk about a bit more later. But apart from all the compositions that he's done and the CDs and music that he's released, he's also worked on Art Angel commissions, for example, taking a music sonic piece around on a London bus. With the Tate Modern, he was one of the first sonic artists to be commissioned. He works with a lot of contemporary ballet choreographers, Russell Mullyfan, Wayne McGregor, and he's also collaborated with a lot of classical musicians. So when we came to this Satie piece, he was very, very enthusiastic about using Vexation, and he liked the idea very much of collaborating on a sound and architecture piece. So we were delighted when he said yes to working with us.
So moving on to the design of the building, this very early sketch showed an idea of how the building would work in its site. We knew at the beginning it was going to be a freestanding building, that it couldn't attach to any buildings around it, and that it was going to have some kind of looping and curving and somewhat ambiguous form where the curves constantly change and move into straight lines and out again within a site which was roughly square, so a sort of round peg in a square hole. And in the early sketches we show the sort of very rough evolution of how the building might be as you come around it. And in its context, again, very early sketch, just showing the relationship. It's an end of back garden site, and then it is next to the first house in a long terrace, but it's very different to them. We decided at an early stage that we wanted to make the building out of concrete. It seemed the obvious thing to do for the kind of form, because we'd be able to make a sculptural object. It would deal with the setbacks and the cantilevers. It would be a moldable object that could take the form of something else. And we looked at different finishes for the building, and we decided quite early that we didn't want to go for, which on the last slide, on the right-hand side, you're familiar, excuse me, with board-marked concrete or béton brut, which we decided we didn't want to do this because we thought, well, why don't we start from scratch, thinking why a building would pretend to be a timber building in that visual sense. So board-marked concrete goes back to a more archaic form of shuttering. You probably, all the architects and engineers will know this. And, you know, it's beautiful stuff, but arguably it has become a little bit of a cliche to use that as the surface finish. So we wanted to use something else. So we decided that we would try and find a form and a material that would wrap the building. And we decided to use a corrugated sheet as the mold for the building. So the whole of the outside skin is cast against galvanized corrugated metal. And this particularly suits the fact that we've got a curve moving that way because the corrugations are vertical and you can bend it around the corner. So just going back to some of the things that I mean, the other thing we liked about the corrugated casting of the concrete was going back to Eric Satie, the idea that the end finished material could be quite ambiguous. You'd be looking in the street at this building and wondering whether it was concrete, whether it was steel, and what it might be made of. This is one of the early models made of bits of paper wrapped around. One of the things we took from Vexation was something that connects back to John Cage's work, because he introduced chance procedures and various means of putting into the composing sequence random elements or accidental elements, which he did through various methods, including throwing the I Ching and other techniques. So one of the early things we did was we printed off the sheet music from Vexations, and we made this model, and then we wrapped the sheet music around the model, and we got a pair of scissors, and wherever the oh, that hasn't come up. Maybe it will.
No, it was there before. There.
Okay, so that's Sarti's theme from Vexation, the left hand, the base line. And we basically got a pair of scissors and stuck it into the model wherever Sarti's notes bounced up and down all the way around the building on the different floors. And that was the first positioning of all the windows in the building. And you can see here under construction, the windows in the ground floor studio, and see how the notes move around. So that was a kind of random element. Obviously, that first positioning, we had to also take into account the more typical architectural things. So, for example, this is the site model, which is the indicator. This one? I don't know, but there you can see the model in the middle. This one? Ah, yes, there it is. So there's the building. So we obviously, there was a view out towards a local landmark church in issues of privacy from surrounding buildings. And so and then, of course, bringing light in and all of that. So that made some adjustments to the window sizes and positions. You can see here how the building just nudges forward of the building line in the street, and this top window gets a view down the road. In 2013, we were invited to make an installation at the Venice Architectural Biennale, which I'm going to hand back to Scanner for that bit.
Right, so Scanner. So what we did for that, we used Vexation as our starting point again, but what Robin and we wanted to do was also incorporate some of the things that were happening in our real world. In that time, what had happened is that the garages had been squatted by some homeless men, and it was a time, and still is a time, when there's a lot of homelessness around. So when we got to Palazzo Moro, which is where the exhibition was to be, we scouted around for a room, and we were really delighted to find one which was between the grand restored part of the palace and the unrestored part of the palace, that sort of liminal space in between. And we chose that to put our installation in. The installation being a one-to-one formwork for the concrete house with some models, plus some sign of the people who were also on our site, sleeping bags, rough cooking equipment, and it sort of had parallels with what we did in our work, which was find derelict sites in the city and then try and make some sense of it with what's happening. And Robin took from his inspiration both Vexation and the presence of these people. It made quite a eerie little piece. The sound, which I think you're going to play, was looped on in continuous loop all throughout the installation, and it made for quite a sort of unsettling experience when you went into the room. And this was the first of the sound collaborations, called Vex in Venice.
Changing between the different media, and also apologies to Phil Hudson, Price and Myers, for the rotation of this slide. Don't know what's happened. So going back to the construction of the concrete, Price and Myers were our engineers, and we had some advice from David Bennett. And this, we wanted the building to look like concrete inside and out. So we said to Price and Myers, we want to have a structure made of some little bits of curved wall, the absolute minimum that you can do that will hold up the upper floors and the whole of the external leaf as well. And so they came up with and I mean, this is in their Revit model. So this shows the inside and the outside together. And what I quite like about this, it reminds me of those forts you get in the Thames estuary out towards Whitstable. So you can see the 6 piles and the building above. And the early sketches to work out how to make the formwork of the building, because where we have 2 skins of concrete, the inner concrete has permanent insulation outside it, which acts as permanent formwork for the outer leaf. And where we don't have an internal wall of concrete, we have timber frame with more insulation. So the whole thing was set out in CAD, of course, with all the curves coming together at tangents so that the different tighter and looser curves come in smoothly into the next and the same into the straight bits. And the starter whalers were set out from the CAD files and CNC cut, and then the contractors set up a little workshop on the site, and they manufactured all the rest of the curved elements based on the templates that they made from the CNC cut ones. So that's obviously starting with the ground floor and then casting the kickers and coming up with the...
There's Marco Curtaz and also Nigel Fanshawe, who were sort of central to getting all of this built. It was a very complicated little bit of work.
So the builders, the carpenters made a fantastic job. So essentially, because we cast 1 story at a time, the whole building, so 3 big pours, and everything was made like this out of curved timbers. So, and these vertical infill, so the whole thing looks like library shelving, and then the vertical twin pairs of soldiers to clamp it all together, and then additional bracing and so on. And you can see it emerging here as a form in the street. In some ways, it would have been beautiful to have that as a building as well. You can see here. So that's the permanent. That's the insulation which forms the permanent shuttering for the inner leaf, and this mesh is sitting in the middle of a thin concrete skin that goes around the outside, the galvanized sheet and the soldiers and the whalers and the soldiers. And of course, it could only be made in panels that could be manhandled on site. So very different to the last building we looked at. Everything here is really handmade on the site. And more music now, because during the construction of the site of the building, the photographer Ellen Binet took a whole series of photographs, these rather nice black and white photographs. So if this works, I'm going to play one of Robin's finished tracks, which is Vex Drift, over a sequence of Ellen's photographs. So that's the next technical challenge, which is this one at the top, isn't it?
Can you get the pictures, Meg?
starts again, I'll have to interrupt it. But otherwise, I'm going to say something now about how Robin made the music.
Yeah. So the final two pieces of music, Vex Drift and Vex Flow, were actually made from the starting point of that recording that we had right at the beginning, or several recordings that we had right at the beginning of the concrete being poured. And Robin felt inspired really to get people to listen to the building being made, and the sounds that he used there was he sampled. I said we'd come back to him sampling the sounds that he found. He actually used the sound of the making of the building to make the music, and he has in his studios this huge modular equipment where he takes the notes and he manipulates them, and he was very particular about the looping feeling that came out of the vexation, the repetition and the looping. And he also took individual notes from Sarti's original vexation, and he manipulated those, he treated them, and he mixed them into the sound of the concrete pour. I'm sure he'd tell you a lot more technically and eloquently than me, but that was the sort of basis of what he did with that. So all of these tracks, actually, that's his mixing play, and we actually went along and listened to him make that. And if you would like to hear a bit more about the collaboration, if you go to our website, there's actually a 5-minute film where we talk about the collaboration. And just a quote from that, I mean, he said, I wanted to make something utterly beautiful, inspired by the shape of Vex, the fluidity about it, which I wanted to reflect in the music, to make something exquisite which offers a sensibility of concrete and of architecture. So he was pretty ambitious about making it site-specific as well. And when we opened in open house this year, we had all 3 tracks playing, one on each floor, and people going through the building. And one of the things we talked to him about was the staging of the music, and he wanted the music to be very much with the building, not something that had landed in the building. He wanted it to feel like it was growing out of the building. So it's conceived really as a very intimate piece, and he didn't want there to be a stage of any sort. He wanted it to be part of the architecture, and he wanted the architecture to be part of the performance piece. And indeed, one of the things we're talking about is having some salon performances there as well, coming over the following year. So we did make a CD.
Yeah, so maybe I should just say, so at some point Robin is going to play live within Vex. He's going to mix the piece live. We've got a list of names of people already from coming to open house who want to, who would like to know about that. So I think if anyone is interested later in hearing about when he does that, the best thing is probably to send us an email or send Elaine an email, so we'll get it. But you were saying?
But I was saying we've got a CD, and actually we'll be we have a few which we will sell you at cost price, which is £2 afterwards for anybody who wants one.
Doing Robin's dirty business for him. Okay, so this is my last attempt to wrestle with the technology. So I'm going to play another of Scanner's tracks. I'm just going to run through a series of slides that show the almost finished building. And then, if there's any time left, we can have some questions or not. So I find that track, which is this one, I think. Miss Gilbert's dog.
Much. Well, it was definitely a first, wasn't it? Music and Concrete Elegance. I think what I found quite interesting about both projects is actually, I mean, the amount of craft and skill that goes into it. Sometimes it's not always obvious to see how much work goes into it. I mean, you didn't even touch on in there the amount of requirement of how, in order to be able to get those corrugations to meet right the way round and there to be, you know, them to meet seamlessly around the back was an extraordinary piece of craftsmanship from the guys on site working it. So brilliant that we've gone to sort of off-site construction and, you know, Revit designed and to handcrafted on site with cutting up bits of paper. I mean, the whole range of how one can use concrete creatively. Really interesting. I've got a question. Before I think what we'll do, if everyone's all right with that, I think that what we're going to do. Anybody got a burning question that they want to ask before I? Okay, we've got a couple, and then we'll finish and have some drinks.
Yeah, I wonder if your client bought into this whole idea with the collaboration of the artist and if you paid for it.
I probably didn't make that completely clear, but what I said at the beginning was that some friends came to us with a derelict site and said, wouldn't it be great if you did something and on that site? So actually what we did, over a period of about 2 years, we negotiated to acquire that site. And so we'll actually develop this at risk ourselves. So about 2 years to get the hold of the site, about 2 years to get planning permission. It should have been a year on site, but it's already a year and a half over that 1 year, and we just about finished. So it's actually taken a long time, but that's the answer. So
great. I'm glad you clarified that bit.
Yeah.
No, there's one more question I saw there.
Do you want to describe anything about the pouring of the concrete? Because you construct it by building walls which you then pour the concrete inside.
Yep.
And then you remove the metal.
Yep.
Then the process of doing this, you did it 3 times? Am I just telling us?
Yeah, I mean, broadly the sequence was that because of the overhangs and the setbacks, we decided not to do it where you would go up with the columns and then the floor and then some more, and then some. We came up from the ground with the columns and the internal sort of curved wall sections, and then having done that, we cast the whole of the ground floor outer leaf and then the slab, and then we went up again with the columns and then the outer leaf. So each time we cast the outer leaf, we had to carry all those panels up on the scaffolding. And we had a whole system for attaching the outer leaf to the inner leaf through the insulation. And we went up, except we changed the sequence at the top. And everything was poured, so we had a concrete mixer and a pump. And then that was like, probably for about 9 months, we'd be doing all the carpentry for a floor. And then in 1 or 2 hours, they would come along with a concrete mixer and fill this little curved sort of eggshell. Very, very, as I've said to Elaine, very exciting but mainly fear during that, because the chance to make anything good. I mean, we've made almost nothing good. I mean, Elaine's seen it. You know, it looks quite slick in this photo, but there's a lot of rough bits to it, and we tried not to make anything good that wasn't just as found, unless the engineers were worried about the cover, you know. The engineers were over there.
And when I visited site, there was some great discussion about glass, hand-blown glass stoppers
Yes.
for the tie bolt hole infills,
Yeah,
which I've
that's
never seen before.
Right, so
Did you go for that?
we did that. You might have, but every one of these little buttons, I don't
So
know,
the tie bolt holes, obviously, what's left once
has
that
got
was
a
what's holding the
hand-blown
formwork
glass
together. Yeah.
stopper in it.
So just another level of craft
Yeah.
and collaboration. That,
Yeah, so they are, oh, now I've taken off the slide, but, well, you can see them here. So each one of these, which is where the shutter bolts go through and clamp the two sides of the formwork together before you pour, because if you're pouring a 3.5 meter high, 100 millimeter thick wall of concrete, even though it's very thin, the forces are enormous. The hydrostatic pressure is enormous. So you have to bolt it all together, and then afterwards we had someone, and he blew, I think it was about 400 hand-blown glass stoppers that we put in afterwards.
little jewels.
I didn't mention that.
Little jewels in the concrete.
It's like those at night.
It can in some places, but because where we don't have inner concrete, we've got basically a timber frame insulated and covered in plasterboard. They can't come through there, but in where there's two skins, they can do.
So the same challenge as John Lewis, to be transparent on a very different scale. Anyway, thank you very much. Can I have a big round of applause for both of our speakers?